Hello, this is a video about the clutch for, in this particular case, this is for my 2009 K1300R. It also pretty much has been unchanged since the inception of the K-bikes, the K1200. A few minor things changed, but basically this is it. And this is what you see when you open up your bike. So this is specific to my bike, which is a 2009 K1300R. I also changed out the slave cylinder to a 1200 because its piston, that is actually the part that pushes on that pin to separate out your plates, is 32 millimeters as opposed to 34, which came with the 1300, or the Oberon, which is 36. The wider, that's the width of the pin, the 32, 34, 36 millimeters. There is a set amount of fluid delivered to that unit by the master cylinder. So the wider you make that piston, the less it's actually going to travel, because that fluid has to spread over a greater area. So I wanted the maximum amount of push throw on my thrust bearing, or thrust adapter. So what you've got here is, this is the thrust adapter I've already said. This is a Belleville washer, Belleville spring. It's actually a spring. So when these are tightened down, this actually kind of folds down into itself. And these tabs you'll see bend down, and that is what creates the spring. It's sort of like preloading the whole thing. Here you've got the basket. This is the anodized one, so it's the last iteration. There's your main drive gear, which drives the basket. So to take some of this apart, this is really about oil and the clunk that this is notorious for. And I really think it's a lot to do with the architecture of this, and not so much the quantity of oil as the distribution of oil within this pack, this whole unit here. But to take this apart, you've got your thrust adapter, which is on a bearing here, so this kind of floats free. And it sits in rests in this housing, which is actually anchored down below. This pin, you can see there's a large nut there that actually goes on the end of the transmission. The shaft from the transmission comes up through this. This bolts onto that. So this actually unit is bolted onto the transmission. And this transmission shaft is hollow. And oil is actually pumped through that shaft to lubricate this. And this thrust adapter, which the slave cylinder pushes against, has channels cut in it. In this case, it has 2 channels. There were various iterations of this, but this was the last one they settled on. And this is a very tight fit within that shaft that's coming out, a tight fit. So oil there's probably a bit that flows out here, but it's mostly driven down these channels. And this is free to spin if this is spinning, or this unit is spinning. Anyways, it's all moving. This is kind of free to float. So you've got the spring here, and you got the nut that comes off. Now we'll take out this whole lamellar pack, which is the guts of the thing here. You're probably familiar with this, but there are slots cut into the side of the basket. This is the basket, this is the hub, and these plates, these friction plates, ride on these teeth, or slots. So it fits in there. So there's a slight bit of play, but that's because they have to be able to float around in there. So this is what is locked to the basket, which is driven by the motor. So this part is always moving. If your engine is turning over, this is turning over. This part is engaged by the steels, which are riding free inside here. They're not engaged with this part, so they're not dependent on the engine moving. They lock into this hub. Now this is locked. This is what is bolted to the transmission shaft. So these two are, the steels and the friction kind of separate. The frictions are driven by the engine. The steels are what connect the frictions to the steels to drive the motorcycle. This one thing I can mention here is that the bearing on here that came with the bike is kind of a cheap. It's a cheap bearing, and it has caused a number of people have noted that the RPMs, I think 3,500 to 4,500, especially when you're off the gas, there's a vibration set up, and it led to people figuring out that it was that bearing. And there is a very good bearing you can buy. It's INA, and there's the number. I don't know if I hope you can see it. It's NK35/30 TVXL, and it's a fairly straightforward thing to do. I think that was about $50 Canadian delivered. So that can go aside. So we are going to talk about the architecture here. All these plates, as you saw, were on here. They alter between a friction steel. So you're alternating between being driven by the engine and connecting up with the transmission. And this is the part we want to focus on for now. This is the hub. This is where the activity takes place, the engagement between the engine and the transmission, your back wheel. Oil. Oil has been coming along through here, out here. And it, if that were there, let's put this together here. Oh, just terminology here. This, I think, is called the hub. This is the pressure plate. It's called the pressure plate because it goes on here, and it's the movable part that will actually create pressure by way of this big spring here. When you disengage a clutch, you're actually pushing that pressure plate away from all the stack of plates here, from this stack. But just to look at the oil, we've got that bolted onto the transmission shaft. This riding within that. And you can effectively look at it as this is going to rest right on those posts. So once that is resting on those posts, and that's where you use these screws to anchor that, how much space do we have for the oil to get distributed from the back of here to wherever this shaft that comes up here? Well, by measuring it out, I found from this surface, not from, because this is slightly recessed in there, from this surface to the end of the actual shaft, you've got about 4.5 millimeters of space. So it's a very small little window of space there that the oil is being flung out of. So that's the amount of space when your clutch is engaged. You're just heading down the highway. You got 4.5 millimeters of space there where the oil is traveling down here and being flung out. Now, when you go and disengage the clutch, it changes this, because what's actually happening is this whole thing is being pushed into the shaft. So this space is going to decrease. How much is it going to decrease by? Like, how much does this slave actually, what's it capable of pushing this? Well, you can get a pretty good idea by taking and stacking your plate. Let's just do it loosely here. Just put it all back together. There's your stack. There's your stack height. Kind of a mess, but there's your stack height. You can see that this is proud of that. Because it's okay. This is being held in place by the basket, the slots in here. So this is being driven by that. But if we take that one off, now for this to work properly and safely, the maximum amount that this pack, when you pull in your clutch and that slave cylinder pushes, the maximum amount it can push is only, so these surfaces are even. If it got beyond that, it's not locking in properly. And if it went off, I mean, it'd cause havoc within there. So that is about how much the slave pushes. And if you measure that, that's about 2 millimeters. So you've got 2 millimeters that the slave is pushing on this. So if you start off with the clutch disengaged and you've got about 4.5 millimeters of exposure here with oil, the ability of oil to fly out, you push on to disengage the clutch, this moves about 2 millimeters. So you're left with 2.5 millimeters, little tiny window of oil. So it's less oil, theoretically, coming out when you disengage the clutch. Okay, so now we know that how much that moves, the slave moves the pack, because it's actually pushing. Like I said, this is the pressure plate. It's pushing. Well, it would have this plate on there too. It's actually just pushing this about 2 millimeters out, about that far. We've got 15 plates in here, and we need 16 spaces between each, because we've got the 15 plus the extra. So you take 16 and divide it into 2 millimeters, and you get 0.125 of a millimeter. That is incredibly small. That's the amount of room or space allowance between each plate. So it's very, very small. So you can start to appreciate why extra oil in there would cause that fluid coupling, which leads to the huge clunk. So the oil environment of this is kind of a critical balance. It needs to be low enough when you disengage the clutch that the fluid coupling is not an issue. It does break. But you need enough oil for the oil to perform its function, which is to lubricate, of course, to make things slide evenly against each other and no wear. It's also there to remove heat from this unit. And thirdly, it's there to help wash out debris. All these things are sort of sacrificial because they're rubbing against each other. And especially at the pressure plate surface where that friction rides, and down on the hub, these are both soft materials compared to the steel. So these are what are going to wear and need the lubrication. And they also really need the washing ability to wash the worn stuff off and away, because that stuff is like a fine grit. If you've used polishing compounds are just finer and finer materials, right? And so this happens to be just a very fine material of debris. Part of it's the friction material here, and the other is just the wear on the pressure plate, this aluminum. Now the fluid coupling, I can't illustrate it here because these don't have any oil on it, but they would just stick together. I could literally hold this and this friction would not drop. They stick together. Now, BMW, and that's what causes the clunk. BMW tried to address that with this particular lamellar pack by following the Japanese and putting these little indentations, I hope they show up, indentations in here, actually in the steel. Fluid coupling can be broken by turbulence. Air, and just simply creating more space between the two of them will reduce the potential for any fluid coupling. But we've got, remember, 0.125 of a millimeter. That's really small. It doesn't take much oil to create that. So BMW introduced these dents, as far as to create turbulence. Personally, I did not find any difference. I've compared this with ones that are solid steel, and I didn't notice any difference. Coming back to this is one thing that BMW has changed over the years, is the friction kind of pads. They used to be quite a bit larger. The famous Barnetts, if you look at them, their pads are enormous. They, would almost, between these two tabs would be one pad. Well, BMW kept reducing them down for the flushing action, I believe. So it allows more oil to get through to flush these out. These are actually these are porous. So oil is actually meant to be contained by these and slowly being able to migrate through and remove debris. Also, by making them smaller and all these little channels more frequent, they are introducing more air, or there's the potential to introduce more air. So I think that, again, was why these got reduced down from quite a bit larger, and the Barnetts are the absolute largest, down to these smaller ones. So, oil. We've got oil coming down this shaft and being flung around inside here. Now, remembering that this, as I said earlier, we've got this kind of setup, and this is riding right like that. Now, if you look and measure down below, like I said, there's about 4.5 millimeters between this surface. This is recessed a bit, but I measured from this surface to the end of the shaft that comes here. You got about 4.5 millimeters. So when you disengage the clutch, this moves into, the spring is holding it back, but it moves into the shaft and leaves about, 2.5 millimeters of exposure, which is a very small little window of oil between the bottom, I'll just take this all out, between the bottom of this, which is riding about there, bottom of this and there. So there's a little tiny window, and oil is being flung out. This is rotating at high speed this way. So oil is being flung out down those channels and flung out in this direction. Now, there are some videos on YouTube that show these packs, these lamellar packs, being taken apart. And the oil, the wetness, the amount of oil throughout this pack varies quite a bit. There's actually quite a bit of oil on the initial plates in here. Then it goes kind of dry, and then it gets a little wet again when you go through the pack. So the initial part is wet, then it goes dry, and then it gets wet again. So why is that? Why is it all uneven? Well, I won't go into, I'll do something first here and talk about one of BMW's answers to this unevenness was people were experiencing judder. The definition of judder is uneven take-up, uneven kind of grip between these different plates in here. So some have more oil, some have less. So it's an uneven take-up. Some are grabbing, some aren't. So it's like da-da-da-da-da. So what BMW did was, this was a common, I guess, Japanese just approach. This is just a flat, big washer. Goes down there. And its purpose is to prevent wear that this might bring about. This is a spring. Again, it's a Belleville spring, just like this, these conical kind of springs. This happens to be just very small. And it rides with the outer edge farthest away, rides in there. Now there is a specific friction that goes onto there. And then there's the steel that rides on top of this. Now, one of the things that does is the original idea, we call it anti-judder, which is really more of a masking for a problem than dealing with the problem. The problem is the uneven take-up, which means the kind of friction load between each of these plates is uneven, and that's why blah, 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 blah. But what they did was introduce this because that spring is holding the steel away. So this one's, I'm squeezing pretty hard, but this is still free to move. So this is the last part to get compressed. As you release the clutch, the pressure plate is coming back and clamping it all together. And this part is the last part. So it gives it kind of a softer touch, but it actually kind of dampens this stuff. So it's not really addressing the issue. It's more of a masking thing, I think. So we've got that going on there. So the oil, back to the oil being delivered. So we've got that tiny little window of oil coming out. Now, just looking at this hub, it starts to become pretty easy to see why. I don't know if I can get it angled properly here. They've got holes. Well, look here. These holes are delivering the oil, and they deliver the oil to its own little environment. Because each one of these holes, well, let's just throw this on just to give you an idea here. Okay. There. We go around. Okay. There's the hole, an oil hole. And that oil hole is meant to lubricate this plate and the friction that rides against that plate, and this side also, and then the underside of the steel that is just above. So the hole is contained by these tongues of the steel, top and bottom. So the oil is just being delivered into this space, and it's just a passive way, and it seems to work reasonably well anyways, is to flow out onto this steel, to flow out to here, and lubricate the thing. Now the thing is spinning, so, and there's only one hole for each of these levels except the very first one. So the oil is meant to travel all the way around to lubricate that. So there are sequence of holes, and they've done it very, very logically. If you look at the holes here, there's an oil hole here, and then it moves down, and then down, and then down, and then down, and down, and down, and finally down to the hub. The hub is the only place where there are two holes, and the other hole is at 180 degrees. So there is lots of oil coming to that hole because we've got two holes as opposed to one elsewhere. But back to this, you see the oil, if you remember, it's just that tiny little window that it's got, like, 4.5 millimeters when it's disengaged, or engaged, and roughly 2.5 when it's disengaged. So it's a tiny little window of spray coming down here. And so you can see that if the oil is spraying down, it's directly coming down towards these holes. So these holes represent these first few plates here. The kind of the midsection here, or what would that be? Maybe roughly, I don't know, 3/5 of the way in, is actually within this casting here. And they've cut channels here to kind of, the idea was to let oil flow down there, and then those channels have their specific holes to oil specific areas. But the ones that are the driest are the ones that are within this. Partly why that is, the lack of oil in those middle parts. First of all, we've got lots of oil, right, because it's directly under where it's spraying, but a lack of oil back there. If you take a rod and put it through, I'm going to put it through here. That's the little channel where the oil is supposed to flow. And you put that rod through there and just get on the casting. It's a teeter-totter. There's a ridge, and no matter where you go, it's always the same. So that little ridge in the middle there means the oil has to kind of go up over this hump and then flow down. I don't know why that hump is there, but liquids don't like to flow uphill. And this part is actually sloped away from here, so the oil spraying down is going to want to drool off. And remember, this thing is traveling at a furious rate, spinning this way, so you've got a lot of force actually to spray oil off. They've got these little wings, which I guess are partly structural, but they also act like little dams. So as this is spinning and the oil comes out, hits here, starts to migrate down, it hits this and basically it creates a little backlog of oil. And so I guess the idea was it filled up enough that some would drain over. But it obviously doesn't work because the part in the, if it does, it's going rapidly over that peak in the middle, and that would indicate why these are kind of dry. So yeah, these help, or that was the idea anyways, they help encourage oil to go back there. So that kind of points out, why this part's dry, because it's within this part where that little ridge is. And why this is so bloody wet in here is because it's directly under where the oil is spraying out. Oil to the pressure plate is really very passive. If you're relying simply on the oil going down these channels, initially kind of like, oh yeah, that makes sense. Oil flowing down here, and this fits with these kind of indexed little ribs, fits in there. So okay, yeah, it's going to come down there, and then it's going to flow out onto here and lubricate it. But it doesn't really work that way. This is traveling, spinning very fast, so the centripetal force is incredible. So when the oil comes along, it's not going to flow straight out and run into the pressure plate. No, it's going to come here, and it's going to want to go right off, fly right off. Well, actually, it'll fly off into the first friction in steel. Excuse me. So the amount of oil it gets here is really not as direct and purposeful as these holes are. When this is in place, you got the nut here, so just looking at, that you've got the space, and then this thing riding just above that. You got that little space. So what the pressure plate's relying on is the oil coming out and hitting these posts and sort of spraying around or drooling around. And probably there's quite a bit of chaos as far as the atmosphere in there. And some of it inevitably is going to go down here or drool down, not drool down, but run down these posts. And that is what would come down here, or having been flung erratically into here. And as this is spinning, it goes down in this trough and then is delivered out through these cuts to oil the rest of the pressure plate. So it's kind of you can understand why this does not get enough oil. It's a little too passive the way it's set up. There was a comment somebody made that at one time BMW had made a little propeller of some sort that was, I believe, I'm guessing, held in place by the nut, and to create more of a turbulence and atmospheric turbulence in there to drive oil more evenly around the thing. As it is, it's probably a pretty turbulent atmosphere in there. Yes. Now, drag, this clutch, or I should say fluid coupling, is the main problem with this clunk. And we can see that, okay, they were dry here, kind of wet here, but down here they were really soaked. So this is probably where it's happening most. And where it's very likely to happen is right at this point here. And it's because of that, coming back to that little environment I was talking about, where you've got the washer to save the aluminum, and then you've got the Belleville washer, and then you'd have a steel on top of that. So we've got, where are those? We've got the holes here delivering oil, another one at 180 degrees, to this environment right here, which is an enclosed space. And even though this, when it's under pressure, this is still free to move, it wouldn't take much oil in there to create that fluid drag. And with a ton of oil coming in because of two holes, and those two holes being located right in the direct path of the oil, there's going to be a lot of oil in that area. And the way they distribute the oil is, well, the added part here. You can see there's a little machined trough here. And that little machined trough is to allow oil that comes out the hole. Now remember, there's the washer here, and then the steel riding on top of that. So that's creating that little environment. The oil can't go anywhere, right? But on the underside of that, the underside of the steel that's on top of that, so this underside is going to get some oil. But most of it's going to go under there and help oil this. But we've got two, so it's going to be more oil than any of the other plates because we got two distributing oil. So as this thing spins, we're getting a lot more oil evenly distributed there, which is going to help with the fluid coupling. If it were uneven, parts dry, part wet, it would probably break a lot easier than that. Let's see, have I covered what I wanted to? There's one other kind of interesting part here, and that is to do with this pin. I don't know if you can see here, but there, like I pointed out, there are two slots. And this thing is free to spin because it's riding at its own bearing, and it's riding with a small tolerance in here, so it's free to spin and not grind away. You can see where it's rubbed there. It's quite shiny. But anytime you've got something really spinning at potentially really high speeds, you want it balanced. And to cut slots that are not opposite, like that would have been my first thought, is do it opposite. Then the thing is balanced. And then it will rotate right on the dead center. Do it off, and you change the center of rotation by having those two slots that way. So there must have been an important reason why they did that. And others may have ideas to contribute to this, but the one thing I came up with was looking at where those slots are once the thing is located. If I just hold it, you won't be able to see this very easily, but there's a slot right here that lines up between those two, no slot, and the other slot lines up here. So as this thing, so it's spreading oil. If you look at an instant shot of what's going on here, oil spraying here and oil spraying here. It rotates, oil spraying here, oil spraying here. It rotates, oil spraying here, oil spraying there. So what it's doing is creating two little spurts of oil. So it's one, and then it moves. One, so it's like. My guess is they were doing that because the oil can drain through these holes only so fast. So the first hole gets hit with the oil from the first slot, and it allows it to start draining before it's delivered the second amount of oil. So it just doesn't get wasted by getting thrown off. That was one of their ideas, I think, about delivering more oil. or oil that's effective anyways, trying to spread out the time that it's being delivered. But that's a curious thing, but it was quite deliberate. Oh, let's see. So I guess that's probably about it. It's really, in my mind, the oil distribution. So you've got a hub that is receiving oil, part of it here, very directly, so those plates are going to get very wet. You've got these channels with a hump in them that don't encourage as much oil as it could to go through there. And because of the hump, that may be why the center parts are drier. Oil is going across, the oil that does make it across is going kind of across the peak and getting down the other side. And the fact that this is very passive in how it receives its oil. Yeah, that's kind of the most important points. The other little telltale you can see here. You can see these little marks are actually they're actually where the steels have impacted. So the steel's on, riding on the hub. Get in there, you. And there's a little tolerance. So the increasing, decreasing in RPMs, the starting and stopping, it's impacting these teeth, these slots. And it shows. You can see these shiny marks. And I'm just trying to find one that's a good illustration. Oh, this one's not too bad. Now, remembering the amount of space, once you pull the clutch in, the slave has pushed the pressure plate away and allowed the plates to slide. The plate that's here needs to move moves that 0.125. As we know out here, we can see there was 2 millimeters between the top of the steel and this outer edge. So it's got 2 millimeters to move. So it's got a lot to move. So if you look at the little impact spots, that's fairly small. So it hasn't shifted much. And you can see it getting a little wider, a little wider, a little wider, a little wider, and very wide. So there's kind of a telltale that, I can see that the plates are moving. What it doesn't tell, though, it's not an indication of really the normal function of the clutch, because there could be fluid coupling going on at one time in this area, and so these don't move. And it's just inconsistent. It's mainly just, yes, you can see, they do move. Overall, it's moving, but it's incredibly inconsistent because of the oil distribution unevenness in there. So I think that's probably it. I have made some modifications. I'm working on modifications. I'll go into that in another time. I just wanted to look at the architecture of this thing right now and what's going on with the oil, with the castings, and how that oil is getting around inside that thing, or not properly. Okay, I hope this is of some use and people have found it interesting. Okay, thank you very much.